Yep. Good morning, everyone. Welcome to another beautiful day in the neighborhood. All right. So something I've been neglecting, it's very, very sad to me, is the joke of the day. Remind me if I ever forget this. Angelina's going to tell it to you. So, to give you some background, in high school, my wife made my lunch. Very kind to her. And in the first couple of years, she'd write like, I love you, have a great day, that kind of thing. And on the back, she looked up a bunch of jokes. She curated, looked online and tried to find good kind of wordplay jokes. So I have a lot of them. I have enough for every day of a high school year, which is far more than enough for this class. So, remind me if I ever forget. I'll try to have a bag of them just in my backpack so I have them on hand. And I've just been forgetting every single class in the chaos. But moving forward, now you know. So if I forget, you need to remember. This is very important.
I used to make sandcastles with my grandfather until I was told to put the urn back.
Oh, yeah, that one's that one's dark. There's only a few that dark. It is one of my. Yeah, that one's pretty good. Tell your friends. Yeah. Oh man. Yeah, I always forget that one's in there, and then I don't get people. And you didn't give people a heads up. It was dark. It's fine. It's fine. Oh, did I not turn on things? All right, so we're doing the kinematics equations today. I turned up the volume, but I forgot to turn on the projectors. Descend my projectors. So last class we started 1D kinematics. We had a lot of fun, so good. We introduced position, displacement, velocity, acceleration, all the vocab words. And we introduced their corresponding units, and it was a good time. At the very end, I hit you all with a big slide of 5 or 6 equations, and you said, that looks, I don't know what you thought, but it's a lot of equations. And so today, we are going to be working through applying those equations. And what I want to let you all know before you even start working with them, always the question people ask is, which equation do I use for this problem? How do I know which equation to use? That's always the question, and it's a valid question. And the rule of thumb is go through the 4-step process. What is given? What is missing? Find the equation that has that information. That is the secret sauce. That is how you solve any problem in this class when you're trying to decide what equation. What's given, what's missing, find the equation that relates those. It sounds trivial, but that is the thought process. That is how you figure this all out. So, we're going to be doing some examples of that. We'll walk through them. We'll spend a good amount of time on it. It might roll a little bit into this upcoming week. In which case I'll extend the quiz and stuff like that. That's just how kinematics goes. It's a good chunk of stuff. So it may look like we're near the end of the PowerPoint, but this stuff's going to take a bit of time. So here they are in all their equation-y goodness. Oh, sorry, this is the derivations for it. This one's really messy, so I'm just going to copy and paste this over and then delete all the ink on it. So this is your bread and butter. This is your toolbox. And then you have to decide, do I need a screwdriver? Do I need a hammer? Do I need a Phillips head? Do I need, just like you would solve a problem in the workshop if you're ever building something. What, do I use a hammer or a drill? Depends on what you have. Depends on what you need. Same thing here. Same logic applies to life. All right. Also, we're going to try something out. I won't do it right now. I'll wait a few more minutes. So attendance, I do not trust iClicker. And your all's geolocation of your phone. I'm still going to have that kind of in the background as like a secondary check, but I'm also going to try using UCF here. UCF here is something that seems to be pretty useful. People have had good experiences with it. So in a few minutes, I'll open up one of those UCF things. I do stream the class, and so during that time when that's open, I will just do the magical thing of, oh no, they can't see my display anymore. So it still will be only if you're in class will you be able to kind of be marked as it present. So we'll try that out. That'll kind of give us a backup for attendance. We're also doing a lab today. So second half of the class, we're going to do a lab. I've actually written up a document for it. So that'll be a nice kind of set of instructions. You can actually already see it. It's basically going to be going through the same process we did last week, but with a cart going down an inclined plane and related to the kinematics equations and all that kind of jazz. So it's going to be good practice for you all in collecting data, analyzing the data, and applying it within the context of this class. So good stuff. But I will do attendance. So after the break, and we kind of come back in, I'll wait a few minutes. After a few minutes of us kind of starting the lab, I will do attendance again. So the way the lab grading is going to work is you're going to assign yourself to groups, three person maximum. So each group can only have up to 3 people. And then the TA, this will make their life easier. When they input a grade, it'll assign to everyone in the group. Now, if you are absent, you all are here, so it's not going to be a problem. If you are absent after the fact, we'll go and check attendance, and then anyone that was absent doesn't get the points without that. So fairly straightforward. So I mentioned that because the result of that is everyone, no matter whether or not they're here, will end up getting points, but then after the fact, it will get corrected. That's just the process. So I'm just trying to avoid emails of someone saying, hey, I got points for the lab, then why do the points taken away? It's because you weren't marked here as present, but we're going to have the UCF here thing. That should hopefully does it give you all kind of a notification when you're marked as present, hopefully? Give you some check mark. Yeah, great. Okay, so it notifies you if it's working. And therefore, if it's not working, you'll be able to just tell one of us and we'll write down your name or something. So you all get instant feedback on whether or not it actually marked you as present, which is good. So it kind of puts it on you all. You know whether or not it marked you as present. If it doesn't, that'll be on you to kind of notify us. And the other, so that's that. And I think that's it. We can go ahead and get chugging. Reminder, your all's quiz is this Saturday. If you haven't started yet, you need to start it ASAP, so you don't forget about it. One of these days, I will show you all the statistics from last semester and how many people, I'll show you all the grade distribution and I'll show you all how many quizzes were missed on average. I'll do a histogram of that. Just to show you all the people that got lower grades last year were basically the people that didn't do the work. You'll find that's really common in a lot of your classes. That's how these things go. All right, great. Problem solving process. What are givens? What are solving? Sometimes, so step 3, sometimes you won't have an equation that does everything for you, but maybe you can use an equation to find something else and then use that to then solve the problem. We call those 2-step problems. Sometimes you have to solve for something and then use that to solve for something else. We'll see some examples of that. We'll see lots of examples of that. Okay, so let's start nice and easy. This is kind of one of the really simple ones. So a nice softball. After making contact, and the iClicker says, I'm here. And it gets in your way. Yeah, there's no way to get around that. All right, something about an airplane. Something about it coming to rest. Something about 8 seconds. I'll read it once the iClicker thing goes away. But for now, get out your calculator. Your wonderful LA was so kind and did put the equations around the room. Note the little dashes in front. Those are bullet points, not negative signs. So just don't mix that up. But, pro tip. You all generally, this is a good strategy. When you all are working in my class, I give you all the formula sheet. I highly recommend that you all print out that formula sheet or have it on your device. And when you're solving problems, have that available to you. Makes your life super easy. Just have the formula sheet on hand, always kind of visible. Otherwise, you're going to be flipping back and forth between things and trying to find it. You will need these equations. If you have them all memorized already, kudos to you. You probably have already taken all the physics. But very likely, most of y'all, this is new. All right, so, boom. After making contact with the runway, an airplane comes to rest. So it is flying, and then it hits the ground, and it comes to rest. We're going to treat this as a one-dimensional problem. I'm going to go ahead and straight up tell you that. So after hitting the runway, eventually it comes to rest. After uniform decelerating at negative 20 meters per second squared for 8 seconds. What is the final velocity? Nice softball for y'all. Yeah. Yeah, once you see it, you see it.
Yeah.
I won't give away too much. Check with your group members. If you haven't seen it yet, I can almost guarantee you someone around you has. Doing it? We'll jump in. Because great. All right, we're only gonna go for like 20 more seconds. All right, and I will close this out in. No, the question is okay. Good, I did make this visible again. 5, 4, 3, 2, 1. Boom. All right. What's the answer? You all had it for me. You're the only people I asked.
0 meters per second.
It's 0 meters per second. Why?
Because it's at rest.
Because it ends at rest. All right, great. You didn't have to do any math. So there you go. Again, this is just a reminder that the information you need might be in words versus numbers. That's what I want to mention to y'all. So when you're writing your givens, if you're like, I feel like I'm missing something, sometimes just double check the problem and see if you see at rest, stationary, constant velocity, things like that. All right, now let's make it require math. What is the velocity when it hits the runway? So the plane's coming down, it hits the runway. The second it hits that runway, it starts decelerating. What is its velocity when it hits the runway? And this is where you might intuitively be able to figure this out, in which case that means you have a good understanding of what acceleration is, which is awesome. Otherwise, you may want to reference the equations. The equations will get you there. What's given? Write them down. So to kind of help you all out with this step, step 1, what's given? You already told me that final velocity is 0. The acceleration is negative 20. The negative matters. If you don't put that negative, it's gonna not vibe. It's not gonna go right. Step 2, we are solving for initial velocity. This is the steps. This is the process. And you will see me do these steps in pretty much every single one of these problems, and I will number them. You don't necessarily have to number them on your paper, but you're going to see me do that just to help support you all in kind of developing these skills. The answer is probably pretty obvious, but you can probably just look at the answers and guess, but make sure you know why it is.
What is this acceleration? Because it's like velocity over. It's like velocity.
Okay.
So, do you guys are there?
But I think you have to do the.
There's also an equation.
It just makes sense to me.
The first one will also.
Because of like the units. If you look at units.
So, but I guess
The third one?
integrate the acceleration.
So, the T isn't mean.
And also there's a variation comes
Yeah, so that's what we do it. Yeah, I'm like trying to think
you need to find like
so for you all to do for Kimball. And then it'll be if I give you the code for acceleration, you will convert that to the velocity. That to get. So in this case, yes, you integrate the acceleration. It gives you the first equation. Yeah, it's position, velocity, acceleration. It's useful. And later on, we will have to actually go over the integrals. That's way too much. And they're not. All right, we'll go for like 10 more seconds. Amount of time's already probably been more than enough. All right, yeah, y'all are doing great. All right, we'll close this out in 5, 4, 3, 2, 1. All right, so step 3. What equation are we going to use? Yeah. Okay. Shoot me an email at some point. I can give you the point for it or something. That's one of those I have to kind of go back in and just give you the points. If it's continuing to not work, just mention that to the class and I'll fix it. Oh, don't worry about the location stuff. We're going to do the UCF here thing. That'll be our main way of doing attendance. Oh, really? Have you all experienced this? If the location stuff's on, it doesn't let you answer the question unless you're within the range?
Yeah.
Oh my gosh. Well, another reason for us to use UCF here. Okay, so maybe I will end up just turning off the attendance thing in the future. So with all that in mind, I'm probably not going to count the iClicker stuff today or attendance stuff today. Tuesday will probably be my first day, given we're still sorting things out. Whatever. I'll figure out some way to kind of do that. But to that end, so we'll do what equation, and then I'll do UCF here right after this. And then don't worry if your iClicker is not working. You can either shoot me an email or we're just not worried about it for now. All right, what equation? The first one. So the reminder to you all is that this, so V of t equals V naught plus AT. Remember, this is very important. This V of t is the exact same as V final. They're the same thing. V of t is the velocity at some later time. That's what that means. V parentheses t says the velocity at some later time. So that is the same as Vf. Those are the exact same thing. It's good to kind of write it both ways because it's important for you all to get used to this whole function notation. V of t, x of t, a of t, all that kind of jazz. You're going to see it. But yeah, once you get this equation down, and again, intuitively, you all might have been able to figure this out. If you remember what acceleration is how much my velocity changes every second. So in this case, my velocity is decreasing. Okay, because I'm moving to the right, and the acceleration is negative, that's to the left, we can kind of assume that here, we are slowing down. It says we're slowing down. Do note, and I mentioned this last class, a negative acceleration does not always mean slowing down. A negative acceleration does not always mean slowing down. Easy example of that. We're going to learn about gravity eventually. Gravity is pointed downwards. Gravity is a negative acceleration. If I drop this wallet, it doesn't slow down. It speeds up. That's an easy example to show you all that a negative acceleration does not always mean slowing down. So, anyway, I'll mention it a bunch of times because it's one of the most common mistakes people make. All right, so then you just plug in the numbers, and it's really straightforward. And I put something in the wrong spot. There we go. Leave the variable that you don't know as the variable. If you don't know it, keep it as is. If you do know it, put in the number. And then solve, and you get V naught equals 160, positive 160. With our units in meters per second, again, you probably could have looked at these and that's the only answer that's possibly reasonable. Sometimes you get lucky. On the test and things like that, I will, and even on the quizzes, I will have answers with different units. So I might have an answer that's 160 meters per second. I might have another answer that's 160 meters per second squared. Units are important. 160 meters per second squared is acceleration. 160 meters per second is velocity. They mean vastly different things. It's like going to the store and someone says, get me an apple, and you give them an orange. They're both fruit, but it's not what they wanted. So, units matter. All right. Already kind of mentioned this, but this is just a reminder before we jump into a more involved problem. At rest, stationary, not moving, parked, sitting still, all means v equals 0. And then the other one that we're tacking on to this that we've already kind of mentioned, you already did a problem with this, constant speed, constant velocity means that acceleration is 0. If you ever see the phrase constant speed, constant velocity, that tells you something. That tells you A equals 0. You can write that in your givens. So, keep that in mind. All right. This isn't as bad as it seems. This is just a bunch of words. I can give you a problem that's like 5 paragraphs and it's just as complicated as a problem that's 1 sentence. The amount of words does not determine the complexity of it, but you do need to be able to interpret what's going on here. All right. Assume an intercontinental ballistic missile goes from rest to a suborbital speed of 6.5 kilometers per second in 60 seconds. Maybe they're actually classified. I don't know if you know there. What is the average acceleration in meters per second squared and in multiples of g? I.e., when I ask for average acceleration and it comes to these equations, it's just kind of asking what's A. What's asking for A here? We're just going to kind of smooth that curve and assume it fits in one of our equations. What is the average, what is the acceleration in meters per second squared? Do notes. In meters per second squared. Meters. Kilometers is not meters. This is where you got to be careful with unit conversions. And then, yeah, how many G's is that? So we'll hear the phrase 5 G's, 6 G's. It's literally take the acceleration and divide it by 9.8. So try this out, y'all. See if y'all can get it work together. And the most common mistake that's going to happen here is whether or not you convert your units or not. So, I apologize. I'm totally going to forget if I don't do this again. Let me just open up the UCF here thing, do it now. If I wait till later, I'm going to forget. So I need to practice this. Today, this time, create session. You should be able to get to this through the browser. I don't believe you need to do an app. If you, like, there's the website, here.cdl.ucf.edu. That seems to be the better way. I'm going to leave this up for a bit, because I assume this will take a little while. But this is good practice for all of us. This is my first time using it. I've heard good things. Oh, and if they're online, I guess they get to practice too. Now they don't. I don't know how it works at this point, so that's good practice. I have to remember to do that. I don't know if you can do attendance after the fact. I might actually test that myself. If you need to get up and move around, feel free. Yeah, and this very much, you really want to use the website. I realize the app literally just sends you to the website. So, at least that was my experience with Android. Apple products, maybe it's different. Which, all y'all pretty much have Apple products. At least that's what my high school has had. Maybe that changed in college. Yeah.
I know they took it off the Play Store. It can't scan.
Yeah, that's what it can't scan. No, I need this to work.
Oh, you gotta go.
Oh, you gotta go to that website. Here.ucf. Yeah.
I was just checking like bookmarking it.
Yeah. Yeah. Highly recommend you bookmark it.
Put it on your home.
Yeah. There's an app for the Apple, but not for Android. I have an Android. My wife has Apple. We made it work.
Yeah, I'll have the app.
On Android? Oh.
Yeah, you could probably get it.
Okay.
For it.
Either way, it all works.
Still work.
But be prepared, this is probably how we're going to do attendance moving forward, because clearly I've had enough problems with the geolocation of iClickers that it's not worth the headache. Oh, what is that? Alright, let's try again. And if not, and the beautiful thing about this is that if it's not working, you'll be able to tell me in real time, and we'll just write down your name. And then you'll be marked as present. And it's super easy for us to address, whereas iClicker, it's probably more of a headache. Okay. Well. One day you all will have the pleasure of facilitating something that uses technology, and you'll realize that the best you can do sometimes is the majority, but then you have a backup plan for when everybody fails on you. If it fails on you, I'll have the attendance thing up here. Just kind of raise your hand, and my wonderful LA will find you. All right. We're going to go ahead and call it good at this point, and I'm going to jump back to this and put the stream back on. Boom. All right, there's the problem. Don't forget step 5. Does my answer make sense? Don't forget to ask yourself that question. Does this thing accelerate a lot or a little? Oh no. Oh no. Don't worry about it. Just get the sheet from Leo. There you go. Just raise your hand if you need him to come around and see you. It's not beautiful, but it works. Old school, paper always works.
Oh, that's
So you can experience one. 11 G's. Kind of gets me so fast. Don't want that many 11 G's in life. Kill you. After a minute or two, you'll lock down. Make that fast. Go. Yeah, let's stop this. Alright, good job. Alright, the key is that, and I'll mention this. On humans, if they experience about 10 G's going into so are there any humans on this missile? No, so things accelerate pretty quickly and it's okay. Alright, we're looking pretty good. I'm going to start kind of solving through this. This one is not too tricky. Again, it's kind of more of the same what we did in the last one. But I really hope that you did go through the steps. So step 1, what's given? We start at rest. We then reach a final velocity of 6.5 km per s. When you're writing your givens in this list, I recommend you convert your units immediately. The second you all see a unit that needs to be convert it in the list so you don't have to do it later. So there is 1,000 meters in a kilometer. So I just put E3 after it. That's times 10 to the 3. Boom, unit conversion done. Easy peasy. All right, and then we have the time is 60 seconds. And we say, hey, what are we solving for? Acceleration. We look at our beautiful toolbox and we say, which equation has these things? Has V naught, VF, T, and A. And we are so blessed that one of them actually does. It's the one we've been using. The more you use these, the more familiar you're going to get with them. Oh, and I'm also going to do something here at this point. You don't have to do this now. You can do it later. Something we especially like to do in physics is we like to solve for the variable, do the algebra, before we put numbers in. And I'm specifically saying as like physics majors. Engineering, it depends. So I can move to step 4, plug in the numbers, and then do the algebra. Or, and this is kind of a wild idea, I can do the algebra with these letters. The benefit of doing it with the letters is it's much easier to keep track of what you're doing. You'll see what I mean when I do it. So, for example, I'm going to subtract the V naught over, and then to get acceleration, I divide this whole thing by time, and boom. I made the equation for acceleration. Now I just put the numbers in and hit enter on my calculator. This is easier to check your algebra. Letters, it's easier to follow what moved where. When you put numbers in, numbers get big and messy, and you sometimes combine them together, and you can lose track of the algebra you did. So this is just one of the reasons you'll often see me do this. Honest and physics upper level classes, we don't even use numbers at all. Every problem is just find the equation for this, find the equation for this, find the equation for this, solve for this. If you have this equation, you can solve an infinite number of problems given VF, V naught, and T. I could change any number in this problem, you could solve it. The benefit for you all when it comes to the quizzes is, remember, I only changed one number. So if you set up the equation correctly, and you have it kind of set up like this, when you see the new number, you just change that one number and hit enter in your calculator, assuming you've set up the equation correctly. So anywho, just something you all will notice, it's two different ways of solving it. In this case, I'm going to do it this way. So we have 6.5 E3 minus 0 divided by 60, and that came out to 11.1, I think. 11.05, thank you. I did not do that in my head. No, that's not it. Oh, that's a G. That's a G. Right. See this? Okay. What is the number? 100 and something. 180.08. 108. Boom. All right. 108.3. Thank you. All right. This is a very hard number to interpret. So if y'all remember, I told you 27 meters per second is 60 miles per hour. That's for velocity, not for acceleration. So that gives you a benchmark for what's a reasonable velocity. You all know what 60 miles per hour is, so you can kind of do this conversion in your head. I haven't given you a baseline for meters per second squared for acceleration. So now I'm going to give you a baseline. The baseline is gravity. We're going to see that in class later today. We're going to learn that the acceleration due to gravity later on today is negative 9.8 meters per second squared. This means if you jump off a building, every second your velocity is going to go up by 9.8 downwards. After 1 second of falling, you're traveling 9.8 meters per second. After 2 seconds of falling, you're traveling 2 times that. What's really interesting about this means if you fall for 3 seconds, you're going 60 miles per hour. 9.8 times 3 is bigger than 27. If you so the acceleration due to gravity is a lot more than kind of people like, you tend not to be falling for as long as you think. If you're falling for 3 seconds, you're going to die if you hit the floor. Now, that's ignoring air resistance and all that kind of jazz. But if you're falling for 3 seconds, you're traveling fast. Okay, I mentioned this. That's our baseline for acceleration. Every single one of you is experiencing gravity pulling you down with that, and you're fine. Like when you're falling, you can fall at negative 9.8 meters per second, and you're fine as long as you don't hit something. Now, as that acceleration goes up, it starts to matter. As you, as a person, experience more acceleration, Top Gun is the one I'm going to reference because it's literally my scale for acceleration. They mentioned 5Gs, 6Gs, whatever, 7Gs. So in Top Gun, I don't know, at some point they make the mention that if you're going 10 to 12 Gs, you're going to black out pretty soon, almost instantly probably. Yeah, I haven't looked this up. That's based on the movie, but it's probably somewhere in that ballpark. The reason being, we're going to learn that an object at rest stays at rest, an object in motion stays in motion. That's Newton's laws. In your body is a bunch of stuff. Blood, organs. When you start moving, it's not like every single red blood cell automatically says, oh, better start moving. It's got to get pushed by your body. So when you get accelerated, say I get accelerated forwards. So my body, my physical, the part that's getting pushed will accelerate. All my blood needs a little bit of catch-up time, meaning it's all going to get squished to the back of me. It's like you in a car. When you get accelerated, you get squished to the back. Well, that's what your blood does. So if you experience too much acceleration, your blood will go in the opposite direction of that. If the acceleration is too much, it can't keep up. You need blood in various parts of your body. So if you experience too much acceleration, that blood can't get where it needs to go. And you pass out and eventually die. Anyway, long story short, 10 G's isn't safe for people. 5 G's is also a lot of G's. I think on a roller coaster, you experience like 3 G's, maybe, something like that. 3 to 5 at most. Yeah, I think 3 to 5 at the most on a roller coaster, like extreme roller coaster. That's for a very short period of time. So when you're thinking about a problem, if you have a human being in a situation and you calculate the acceleration as 6 G's, it better be a very extreme situation. Them hitting a wall, something like that. Rockets can accelerate, so this is one of the really interesting kind of thing, maybe it's interesting, design of weapons and stuff, or various crafts of any sort. If humans are in it, you can't accelerate as much because you'll kill the people. When it comes to rockets that don't have people in it, they can push those boundaries. They can go way faster because metal is a lot more resilient than fleshy bits. So, important things to think about. This is fine because there's no humans in it. These are the questions. These are the things you have to think about if you want to check your work. And what was it, 11.1 G's? Something like that? Yeah, let's just call it 11 G's roughly. All right, how do you get that? You divide that by 9.8. Again, gives you a sense of scale. Okay. This one might be too big of a jump. Let me not do as big of a jump here. So I'm going to go to the problem set and find a problem. This next one I had on the slides, what we just did was kind of a level 1 problem. Pretty simple. The next one is kind of level 3. It's like the most complex kinematics I give you. So we're not going to jump that far. So let's pull open the problem set and pick one that is somewhere in between. All right. Yeah, some kind of level 2 problem. All right. Okay. So scroll. There's some graphs. Yeah, this is a good one. We'll do this. All right. A particle moves in a straight line with an initial velocity of 30 meters per second and a constant acceleration of 30 meters per second squared. What is its displacement at t equals 5 seconds, and what is its velocity at the same time?
Also, if anyone needs attendance, still.
Yeah, you still got a chance. I know we're quite late into class, but we're being generous.
Okay.
Write down the givens, write down the missing. Do two.
Will acceleration ever not be constant?
That's a great question. So someone asked a great question. Will acceleration ever not be constant? In this class, acceleration will basically always be constant. The reality is, if it wasn't constant, we would have to do more complex math. We'd actually have to, I'm trying to think, potentially integrate. But I have to think about that more. Acceleration will always be constant in this class. These equations all assume a constant acceleration. That is the only assumption these equations assume, is a constant acceleration. Velocity can change, position can change, time can change. These equations rely upon a constant acceleration. We would have to kind of make new equations within, we'd have to integrate and kind of make new equations if it wasn't. Doing this in your head will be very unpleasant. Like you'll want a calculator at some point, if nothing else. But please do also write down your givens. Practice the steps, y'all. This also lets me kind of go around and look at your papers and kind of see who's stuck and who's not. Slightly more. Okay, so you decide to do the second part first. Nice. And then what are you thinking for what equation did you decide? Oh, I have and all we have to do is check it out. Yeah, we just look through it. So what are we solving for this problem? Yeah. Yeah, and this is the thing that's going to be subtle, and a lot of people aren't going to realize this. So displacement would be this minus this. So basically, if you shift that over, that's what you're solving for. Yeah. So this problem's not asked. Everyone, the vast majority of people in here are probably going to think they're solving for final position, and I'll let you mention that. But yeah, we shift that over. That's why we don't actually know where it starts. So yeah, we look at the rest. You have V naught, initial velocity, perfect. You have time, perfect. You got acceleration. You can use that equation to get what you want. You got the recipe to make the cake. So what's given? That's going to be our first step. And let's start jotting those down, because if you try to just hold in your head what you have, it'll be easy to forget. Oh, it's not this slide.
So you said we're not solving for
We are for part B. Part A is displacement. It says how far has it gone. How far has it traveled in this time? That's displacement. And then part B says what is the velocity at this time. So two different problems. Yeah, we got that one as well. So yeah, you have V, and then is it V initial or V final? Good. Yep. So we want to note that, because that's going to. Yep. A0 next to it. Then acceleration is A. So that'll get its own. And generally lowercase a, the only reason that matters is when you look at the equations, it'll all be lowercase a. Okay, so you got the first, and then what do you think? So what are you thinking for displacement? And actually, let me make a note of this. So for the first one, when it says what is the displacement, I'm kind of going to jump to step 2 here, because I am basically if I had to guess, a lot of people, without realizing it, were solving for final position, and then you have to make an assumption. If you're solving for final position, you had to make an assumption that you started at 0, which is fine. It works out. But it is interesting to note, when it says displacement isn't where you're located. It's how far you've traveled. So most of you all, it won't actually affect your answer at all, but it's just one of those conceptual. This is good to realize. You are not solving for XF. You are solving for final XF minus X naught. You're solving for how far you traveled, your final position minus your initial position. Or if you want to put this differently, these are the same things. which may confuse some of you all. But that is ultimately what you're solving for. So you have to kind of look at the equation and say which one of those has that in it. Because all I would have to do in this problem to make it so that if you solve for position, if I said this thing started at x equals 3 meters, I can almost guarantee a lot of people would get the wrong answer then because they find final position, not displacement. You have to solve for what it's asking for. In this case, it's not where am I located, it's how far have I traveled. It's the difference. It matters. Where you're located versus how far you traveled are vastly different things. Anyway, I'll keep swooping around. If you all solve this one, feel free to start number 11, the next one. If you solve this one like this, it was easy, no problem. Try the one after this, the one that I say like is a level 3 problem, because that one, it's good. I really like the next problem. We'll probably do one more practice actually before we even get to the next one, but it is a really good problem, the next one. Alright.
I don't know which one.
Does that make sense?
Yeah, I just want to give you the reason. So we don't technically consider
Pretty fast. That's a lot of acceleration.
Wait, we can do which one?
Yeah, so 5 seconds are going half a kilometer. That's a large distance. But when you're going this fast, you're accelerating this much. Right, or you'll get final velocity.
comes out.
Okay, and then same question, is that reasonable?
Yeah, you just find velocity.
I think it's a good check to feel how fast is that? How fast is that?
Yeah. I'm saying
Roughly 27 miles per hour. Roughly how fast is
Yeah, that's what he was saying. It's like technically that's the right position because we're finding it so way. Yeah.
So what'd you do in your head to kind of? Yeah, 27 is kind of like 30. 30 goes through that 6 times, 660. You don't need to have it precise for things like this. If you don't have a position, it's really exact. But being able to do stuff like that, super whatever job. For someone to be able to come up to you and say, hey, if I do this and this, what I'm hoping for you get the problem. This is what will happen. It's not exact. You always sit down and show it. Very easy.
Oh,
Very
I
sorry.
accidentally yeah.
Because some business guys we would get 5 more machines and one product.
This scenario isn't.
You have to use
So we're at 0. So whatever your new position is helpful.
Alright, so let's start hashing this out. And then we'll maybe do one more before we do the challenge one. Okay, what's given, y'all? Step 1. I skipped it, but let's go back to it. What's given? Someone knows this. Y'all got the right answer. Acceleration, what is it? 30, spot on, meters per second squared. That's a lot of acceleration. 3 G's. Great. What else is given? Velocity, initial or final? Initial. Very, very important that you identify this as initial. Get in the habit of, with velocities, you're pretty much always going to have an initial and final. Get used to that. Get used to labeling that. If you do not label it, it will result in a mistake for you later on when you put it in the wrong spot. It will happen. All right, what else is given? One more thing. There we go. Thank you. We got there. All right, we got acceleration, initial velocity, time. And we are solving for xf minus x naught. And we look at our equations, and not a single equation up there says xf minus x naught equals. But you can rearrange some of those equations to get that. Some of those equations up there you can rearrange to get that. You have choices. we have a choice between the third equation and the fourth equation. So if we go back to, you're going to see me kind of do this a bunch. So remember, this is XF. So this one and this one both have XF minus and X naught. So if I want to change this equation, I can just subtract the X naught over. That's displacement. And I have V final plus V naught. Boom. This one I can do the same thing. Just subtract the X naught over. And ta-da! Now I'm solving for displacement. And the question is, which equation do we use? We use the one that we have the information for. We look at the first one. It says VF plus V naught. We don't have VF yet. We will calculate it, but we don't have it yet, so we can't use it yet, unless we calculate VF. The second one, we have V naught, we have T, we have A, we can do it. This is how you decide what equation. You look at the ones, you look at these equations, say, which of the equations has the thing I want? Do I have what it needs? If not, maybe you have to do an extra calculation here or there, but you can get it done. All right, so we're going to choose that last one. So XF minus X naught equals V naught T plus 1/2 AT squared. This is displacement. That's really important for you all to remember what the word displacement means mathematically. And so we just put in our numbers, 30 times 5 plus 1/2 times 30 times 5 squared. And someone tell me that's something, 500 something, 525. Again, I did not do that math in my head. I could try, and I'd probably give myself a 70% success rate of doing it right. And it would take me longer, and it's not worth. I walked around and someone had 500 something. So, anytime y'all see me just spit out a number, I don't have it. I did not do it in my head. So don't get in the habit of trying to do what it seems like I'm doing. All right, great. And then you're solving for final velocity later on. Oh, we do have to ask ourselves, does this make sense? The thing is traveling at roughly 60 miles per hour to begin with, and it's accelerating a lot. So yeah, in 5 seconds, this thing's going to go 1/2 kilometer. That's pretty fast. Yeah, thank you. My unit's jank here. Great catch. We solve for displacement, not velocity. Thank you. Do be careful on these things. 1/2 kilometer in 5 seconds is really fast. If you travel 1/2 kilometer in 5 seconds, you are going at a ridiculously fast velocity. You can do the math and figure out how fast that is at a constant velocity. All right, for the second part, I'm kind of going to just chuck it up here. This is the easier one. We've done this a bunch of times already. You solve for final velocity using the equation. We did that for the last 2 problems, so I'm not going to bother with that one. Okay, we're going to do one more before we jump to this one. We're going to do one more before I jump to this one because, again, this one's a good time. Let's see. We can't do the gravity ones yet, which is very sad for us, but we'll get there. We're going to do this one. How long does it take? Because we actually get... All right, so this is the one we're going to do. This is... And look at this. The blessing to you all is look at all these problem set problems we're doing in class. You don't have to do them outside of class. I do recommend at some point, if you didn't know how to do these, still do them outside of class. But if you got it, great. Less to prepare for. All right, swan in a lake gets airborne by flapping its wings and running on top of the water. If the swan must reach a velocity of 6 meters per second to take off and accelerates from rest at an average rate of 0.35 meters per second squared, how far will it travel? How long does this take? And this is what, number 10. The cool thing with these is if you just put what a problem it is, you'll have the record of what, you don't need to kind of write this out word for word because it is in the problem set and I'll also upload these. Also, when you're solving it, this is the beauty of writing down your givens, writing down your missing. Once you write down step 1 and step 2, as long as you have everything, you don't have to read the problem again. Which is nice when your problem is a paragraph. Organizing your information makes your calculations more efficient. Here, I'll even put the answers up so y'all can check your work. Yeah, it's always good to know if you're actually doing it right. And that's true of you and me. I will tell you all, I don't know if this is how fast the swan has to travel to actually get off the ground.
Maybe.
Oh yeah, it's pretty like very well.
Sure, it's fine. No, I mean, being able to visualize it is it's totally a valid solution.
Oh, it is correct.
You had the other ones beat not, so.
Alright.
What are we solving for? That's the next question. So it's not where I'm located? Oh yeah, displacement. Yeah, so it's gonna be just regular displacement. Yeah, there's final position, there's initial position, and then there's displacement. Displacement is xf minus x naught. You can do that and it'll work out in this specific problem. But more accurately, you're solving for xf minus x naught. That's what you're solving for in the problem. So then you look in the equation like we did last time. Which ones will let me solve for xf minus x naught? Yeah.
So you're doing spiral.
For part B, yeah. For part A, it's how far will it travel?
Technically solving for it.
Yeah. So two different parts. So I'm looking around and you all are doing a great job with the givens, and I think the one that's going to hang people up. So, tell me what's given. Same old, same old. What's given this problem? Initial velocity, what is it? 0. It starts at rest. Great, what else? Final velocity is 6. And one more. Acceleration is 0.35 ms squared. If at any point you're still having challenges identifying these, remember the units tell you. Anytime you all see meters per second, that's acceleration. Anytime you see meters per second, that's velocity. The units will tell you. So if you're having any challenges still with identifying givens, that's kind of one of your bread and butter skills is the units. Now, this is the one that I think I've seen the most people paused on. The question asks, how far will it travel? What is our word that represents, we just did it in the last problem, displacement. You are not solving for xf. You are not solving for x initial. You are solving for xf minus x naught. You are solving for how far did it go. The final minus the initial. The final position minus the initial position. And now you look at the equations and you say, which of these equations will let me do this? Which of these equations will let me solve for this kind of xf minus x naught, given what I have? And you have options. Though some of the options might result in an extra step. That's fine. As long as you get to the right answer at the end, I don't care how many steps it takes. Yeah.
Is there like a standard for how many decimal places we should?
2 or 3. Yeah, 2 or 3 is kind of the rule of thumb.
I noticed that if you round the time to just 17.1,
Yeah.
it gives you 51.42 instead of 51.42.
You're within 1 to 2%, you're good. Yep, 1 to 2% is what I'm looking for as far as accuracy. Because ultimately in this class, I don't actually care about the final answer. As weird as that sounds, the only reason the final answer exists is for me to see that you did the process right. The process is what I'm teaching you all. Do I care that you all know that a swan needs to travel 51.43 meters? No. Like, what I do care about is, can you solve it? Yeah. So the process, so the answer just tells me whether or not you did the process right. So if you're within 1 to 2%, you did the process right. And that'll be true of a lot of your classes. They don't care about you. Like, you're never calculating something you're like, oh, I better remember this value for the rest of my life because it's a super important number. That's an interesting kind of. All right, if you don't find the equation. Yeah, it's right there.
I've always considered the point.
Good idea. So did you all do that?
That and stuff like all the stuff like
So this problem, you can do it backwards. You can do the time. And this is a good exercise for showing you all that there's multiple ways to get there. All right, so some of you I'm seeing, this is awesome. There is, when it comes to kinematics equations, there's many ways to get to the right answer. Sometimes you can do it in 1 step, sometimes you do it in 2 steps. Some of you all I've noticed found the time first, and then you use the time to find this. That's fine. If it gets you the right answer, I don't care how many steps it took you. So some of you jumped to step 2, which you may sometimes have to do this in a problem. I may not tell you in part 2 find the time. So like in this problem, if I didn't even have part B, you still could do this. You could still find the time and then use that. So if you find the time, so it looks like for you all finding the time, use this equation. Nice and straightforward. And then you all probably use the same one that I used in the last problem. That's one option. The same step we did in the last problem, xf minus x, whatever, that whole thing. That's one option. Find the time and then do that. The other option is using the last equation on that list. If y'all look at that list up there, so this is one method. The other method is this. Vf squared equals v naught squared plus 2a xf minus x naught. So let's look at that equation. We just go through it. Hey, look, it's got the thing I want. That's what I want to solve for. It's right there. And then we just go through and we check. I've got VF. I've got V naught. I've got A. It's just an algebra problem. You just put in the numbers, solve for that xf minus x naught. So it's 2 ways to do that. So I'll give you all a few more moments if you haven't kind of solved it to try it out, and then we'll kind of try the next one. But this is, the magic trick has been revealed at this point. So at this point, it's just kind of doing algebra. The physics is done. Steps 1, 2, 3 are the physics. Step 4, that's just algebra. Maybe calculus, depending on the problem. How are we doing over here? You all got it? Life is good? Do you have questions? This is where I get paid medium bucks for. Really? What does a swan need to take off? Really? Oh, I'm sorry, y'all. This problem is not reasonable. Turns out a swan needs 13 meters per second to take off. So I'm sorry. I told you I'd give you reasonable problems. This one's unreasonable. But you know, yeah. I wonder if that acceleration. They probably don't need 50 meters. Maybe they need 50 meters. 50 meters is a lot.
Actually, there's some.
Whoa, some need up to 100. That's fine. It's fine. You know, not all geese are built the same. Some are built different. So this geese. Yeah. You know, or this swan. Actually, okay, it's a swan. There's not many types of swan. Whatever. But it's fun things to look up. You can do this in any problem, and you might catch something silly like this. It's just fun. It's interesting to me, at least. Okay. Yeah, that's totally valid. Totally valid. Totally works. And we're gonna find this in this class that there's often multiple ways to do it, and it's often just preference. At some point, we'll get to some two-dimensional problems where you can either do the quadratic formula, or you can do two steps like this one. And so then it's a preference. I tend to try to avoid the quadratic formula as much as possible. There's too many places to mix things up. Yeah, the quadratic formula is a recipe and being precise. Like, it's so easy. Oh, and that's assuming you put the numbers in correct way. Negative b, b squared plus. Yeah, it's very useful. It is a very important equation for you all to know because you will end up having these, like, but if you can avoid it, and kinematics, you can also just solve for different variables. Okay, I am going to put up the next problem. And really, this next one, yes, Given's missing. The next one has kind of an additional layer of complexity in terms of how to set it up. So for the sake of expediency, I'm going to help you all with steps 1 and 2. And step 3 is the challenge. I'm going to go ahead and tell you all preemptively, you don't just use one of those equations up there as is. It's a puzzle. That's just why this stuff's fun. And hopefully this is why you're in this field. You enjoy logical puzzles and things like that. If you can kind of view these this way, it'll make you less miserable. All right. So what's given here? We have 2 people, Pablo and Jacob. Pablo has been decided to be person 1 and Jacob is person 2. This is going to be important, and I've kind of made mentions of this in the past. So Pablo is running in a half marathon at a velocity of 3 meters per second. And then another runner, Jacob, is 50 meters behind Pablo with the same velocity. Jacob begins to accelerate at 0.05 meters per second squared. How long does it take Jacob to reach Pablo? What is the distance covered by Jacob? What is the final velocity of the Jacob? I don't know why it says that, but I'm going to leave it because it's funny. All right. So, Pablo is going at a constant velocity. At no point does it say Pablo speeds up or slows down. It just says he's moving at this velocity. So you have to take that step of saying constant velocity then. Even though it doesn't say the word constant, you can kind of infer that from the problem. Now, here is where I told you all we are in subscripts. We have to put these subscripts of 1 because we have 2 different people. So, the initial velocity of Pablo is the same as the final velocity of Pablo is 3 meters per second. It's a constant. He's at some point later, 5 seconds later, he's traveling at 3 meters per second. 10 seconds later, 3 meters per second. In the beginning, 3 meters per second. We put this 1 next to it because we have to separate Pablo and Jacob. We have to have that in our notation. Otherwise, they'll get mixed up. All right. Another runner, Jacob, is 50 meters behind Pablo with the same velocity. Okay, here's where things are getting a little funky. we get to decide our reference frame. We get to define where 0 is. Where do we want 0 to be in this problem position-wise? Because I said they're behind Pablo, I'm going to say that Pablo is my reference. Pablo is at 0. 0, 0, 0. His location is 0 meters. So we're going to say that Pablo's initial location, so that's his initial, that's him, is 0. Pablo's initial position is 0. X naught, 1 for Pablo. I want y'all to think for a few seconds. Don't shout it out. Think about it for a few seconds. If Pablo is 50 meters behind him, sorry, if Jacob is 50 meters behind, oh my gosh, did I mix things up? No, we're good. We're good. If Jacob, now person 2, is 50 meters behind him, what is his initial position going to be? Just think about it for a few seconds. See if you can come up with an answer. I'll give it to you in 10 seconds. What would be the value of Jacob's position then? If he's 50 meters behind him, his initial position is negative 50. All right. So that was kind of a little tricky thing we had to do. We had to decide who's at 0, like where's our 0? We had to define that. We have 2 different people relative to each other. Okay, Jacob begins to accelerate at 0.05 seconds. So that's the acceleration of Jacob. And if you want, instead of 1s and 2s, you could put J's and P's. If that's easier to keep track of, you can put whatever you want. You just need to know that they're different. You just need to be able to distinguish between them. I choose 1s and 2s because we just use 1s and 2s and 3s and 4s a lot in this class. All right, at 0.05 meters per second squared. And that's kind of... Okay, there is one more piece of information we can put here. It doesn't specify Jacob, so I should have specified this in the problem. Jacob starts at rest. It's not clear here. We kind of have to assume that, which isn't maybe super clear. Jacob starts at rest. Oh, did I lie? Oh my gosh, thank you everyone. I misread it. Jacob is the same velocity. All right, great. My apologies, everyone. This is why I got a class of 100 of y'all, to catch my mistakes, right? All right, velocity of Jacob is, where is that? Just in case you missed that. Same velocity, so that is 3 meters per second. Okay. So, let's visualize this. There's a lot of information going on here. You know what helps us visualize this problem? A picture. Wild, right? Here's Jacob. Here's Pablo. So Pablo here is moving at 3 meters per second. Jacob's moving at 3 meters per second. They would never catch each other if they stayed at the same velocity. If they stay at the same velocity, they'll always stay 50 meters away from each other. But he's accelerating. He will eventually catch up because he's getting faster and faster and faster and faster and faster. So he will eventually catch up. You know, if you're driving in your car and someone behind you is going the same speed, if they hit the gas and start accelerating, they'll eventually catch up. Makes sense. Okay. Step 2. Again, this problem is involved. This is a problem that you all want to make sure you can solve without seeing the solution in front of you. We're going to work through it today. You should practice. Pretty much everyone here should try to practice this problem without seeing any of my writing or any of your writing. Start this problem completely fresh outside of class. If you can do this problem, that shows you have a lot of, you've got a bunch of skills checked off. If you try to solve this problem later on, you're just looking at the solutions, you're not practicing the way the test is going to look. When I give you the test, you're not going to have a bunch of solutions next to you that you can just reference. All right, so to that end, Step 2. How long does it take Jacob to reach Pablo? We are solving for time. But this time is special. There's a special qualifier to this time. When Jacob reaches Pablo. This problem is saying, so this is my initial. We're going to put I for initial. This is my initial setup. If we draw a picture of the final, what's going on in the final? They caught up to each other. And I'm going to give you all 10, 20 seconds to think about. That tells us something about some variables. That tells you something about some of the variables. I want y'all to think about it. You know what, I'm going to give you more than 10, 20 seconds. See if y'all can figure it out. We'll go around and ask y'all questions. This is a time when something special happens with some variables. See if y'all can figure out what that is. There's some relationship between some variables at that exact moment. You might be able to figure it out from the picture. We'll go around and check with you all and kind of see who can figure it out. It's a puzzle. You might be able to. Yeah, they end up canceling. They do end up canceling. Figure out what variable at the point they need something special to happen. People are located. If they're located at the same spot, what variable corresponds to location? If they're located at the same spot, what variable corresponds to location? How goes the puzzling? Have y'all figured out what variable they share in common at that? So time they share in common. There's another variable that will be equivalent. Their final position will be the same. We're going to do that to figure out our equation. Alright, y'all figured out? Did you figure out what variable they have in common at that point? And that's going to let us do some things. So we have an equation for final position. So we can find the final. We have an equation for the final position of one. And we have an equation for the final position of the other one. And if they're both the same number, what can we do? Equal to each other. That's why this is level 3. All right. So what variable do they share in common? Who's got confidence? I went around and asked a couple people. So they share confidence. The final x position is the same. The final x position. So this is the time at which the position of Pablo is the same as the position of Jacob. This is very important. You cannot solve this problem unless you realize this. And this is where I told you all, we're not just going to use one of those equations, plug in numbers, and call it a day. So we look at our equations over there. We have equations for the final position. So we know xf equals x naught plus v naught t plus 1/2 at squared. We know the equation that we can use. We know their initial velocity. We know their acceleration. We don't know their time. So we don't know time, so we can't solve for xf. But here is the step, the big brain move right now. Here is the position for one of them. Here is the position for the other person. They share the same time, so we don't have to clarify those. We have two equations for position that are equal to each other. It's a puzzle. Like this problem, that's you're going to find a lot of your all's puzzles are just logic. Any puzzle that you ever given to kind of solve is a logical puzzle. These problems, that's what they are. They are puzzles. They are logical things. You got to figure out all the logic to make it work. So long story short, you can set these equal to each other. You can set these equal to each other, and we do have to clarify the 1s and the 2s. So you can set them equal to each other, and then solve for time. So try it out. I'll give you all the answer. This is the hard part. B and C are, once you get the time, it's easy. So for this problem, we're just going to do part A right now. If you want to do the other ones, great. Let me get the answer for y'all. Do not use this answer to work backwards because, again, that's not what the test is going to look like. So don't get in that bad habit. I'm giving you all the answers so you can check it. Do not use the answer to work backwards because that's not how the test is going to look. Solve this problem the way you're going to have to solve it on the test. Set those equal to each other. Put the things in. Do some algebra.
Yeah, I have that as well.
Yeah. So he's not accelerating. And we didn't write the acceleration of Pablo here. Pablo is going at a constant velocity, so what is his acceleration? Zero. Yeah. So if they're going at a constant velocity, it tells you it's 0. Yeah. That's a great question. That's one of those, like, we didn't write down our givens, but we could have. Which would have helped us here. When it comes to 1D kinematics, this is as hard as it gets. For our class. What'd you do? Sure, that's fine. Yeah, there's always more.
Oh, it's because we have the 50 meters. You can put mouse.
Oh, yeah. Okay, so that's Pablo's. Okay.
We have to separate. We're finding time.
Okay. So then you took that. So you actually did the same X file. You said completion hours. You just had to. So you so Pablo you did this one. This is 0. This is 3 times 2, and this acceleration is 0. So you actually did the same thing. Yeah. No, that's totally different. It works. What's cool is, yeah, that is you said this curve means that is better. We don't know what it is. That's awesome. No, look, sometimes things will look different. To get to the answer, that's generally yeah, that's great. Well, I just want to cool, have fun at math stuff. Math stuff gets so I want to use the word insecure, you get to some point where not. There gets to some math. And every point physically, so like I can like, oh, that's what I'm doing. Math at some point, I'm like, I have no idea. It's math, it's a job. Okay. Are people in this department think that's what they do? Yeah, that is. So I respect a lot of people just like that. It's logic. Yeah, it's good.
Oh, you can't find it.
Some theoretical physics. I don't know what you're doing. How are you doing that? How are you? Oh, and at this point, we'll go ahead and enter into the break. We'll come back at like, so if you're still working on this break, 9:35 is when we'll reconvene. So if you finish early, great, but that'll give kind of 5 minutes, and then at least everyone gets a 5-minute break, and then we'll move to the lab. How are we feeling over here, y'all? Not much. She does Wordle and Connections. Did this go smoothly? That's what I'm here for. Oh, so they both don't have the same acceleration. So Pablo, his acceleration is not accelerating. So Pablo's velocity stays the same. And so we didn't write it in our givens, but so that's yeah. What is the acceleration of Pablo? If he's going at a constant velocity, what's his acceleration? It's one of those I didn't write it up there. Because you do the end of it. Yeah, that term will go away, whatever. Yep. And then it's just a math problem. Yep. So today I'm not going to Tuesday. Oh, you're 5 minutes late? I was good to know. Like, so in general, like I'll do like saying something here, and it's wait a minute, and then like but I'm also doing it again or it's like a Cuban no, this class started. Yes, there's the That's the lab. Yeah, the lab. This is studio class. This isn't a lab. Oh well. This is the first week for lab. Shoot me an email on the lab coordinator. It is the class with the lab. She has she has a separate lab. Yes, you're not actually late to your lab. So this lab is in room 339, which is one of the rooms of the yeah, that's all like 5 minutes late. But hey, it worked out. You're not actually late to your lab. You got 2 minutes to walk across the hallway. Oh, it worked out. Everything worked out. Nice to meet you. Have a great life. Good luck with the lab.
Once they get back from their break, they'll probably make an announcement about like
no, I can make it
they have around. There's like space over there. I feel like if they're trying to set up a ramp on here, it might.
Yeah, that's right.
Yeah, I mean that's fine. Like when they're like, but I feel like with the ramp, they're not.
That's a good point. I'll make a mention of it. Yeah, it's like yeah. No, that's my high schoolers. They never called anything. No worries. But I will. How things look so far? But like, I mean, it's kind of hard when you don't have and that's the trap I don't want them to fall into. Oh, they saw me do it then. Yeah. Not because I know that.
Oh, my goodness.
I was gonna do it.
Oh, you're using it. Wait, did you? Okay, so this is, what is the distance covered? So distance covered is not minus 3. Yep, that entire term is what you're counting. This is again that difference. XF is where you're loading it, not how far you go. It's good stuff.
How's that? You
So you're just
20 minutes.
How are y'all feeling?
canceling out the very
The real test is on the problems without seeing them. You basically rebuild the problem without seeing it. That'll be what I recommend, and that's where I'm like, that's what you'll want to practice outside of class. Without the read, yeah. Basically, if I gave you this problem on a test, could you solve it? Without.
Yeah. Solve it for like how long it takes to get the we're going almost the same speed.
Yep.
Does it really matter that or at least
They do end up canceling it. I mean, so when you set up the equation, when you set it equal to each other, the V naught T and the V naught T end up subtracting them on there.
yeah, because I was thinking about that before.
Yeah, it's good.
And then I was like, oh, it's probably dumb.
No, and that's the cool thing. The math always should map. So if you're doing the math correct, that's kind of your baseline. The math will give you always the most precision, and then you have to check your understanding kind of to that, or vice versa. You know, it goes both ways.
Just like if they're both moving at the same speed, that's like
Now, one of them will accelerate.
yeah. So
And
that
so-
one's the one that matters.
Yeah, so interesting enough, you could basically do this problem as they both start at rest,
Yeah.
and then Pablo at rest starts accelerating.
Yeah.
How long does it take him to reach him? You could also do this problem the same way, which is kind of interesting. Yeah, and that gets into the whole reference frames. If both people are traveling the same velocity, you can actually make that number whatever you want. 0, 3, velocity is all relative. Which is a really interesting and weird idea. Yeah, people are so used to like, no, velocity is not relative, but it's really easy to come up with one. In the train, you look down, you're not moving. You look out the window, you're moving. And you just discovered that it's all relative. Yeah, it's a great point. I'll actually maybe mention that after the break that you can conceptually think about this that same way. What's up? Solving for, yeah, because in part B, what are you solving for? You're not solving for the final position.
Just like same community.
You're solving for this, the same thing that we did in the other day. Yeah. So you can see, yeah, if you ignored ID, if you just move that over and solve for displacement. Yeah, exactly. No, it's a great point. Yeah, displacement doesn't care about reference frame. Yeah.
Well, okay, you're
Yeah, so I'm actually going to mention that because they're both traveling the same velocity, you can basically extend this problem instead. They both start out moving, and then Pablo starts accelerating. How long does it take to reach it? Yep. It ends up conceptually being the exact same problem, which is cool. But to realize that, you have to realize that velocity is relative, and also you can see it mathematically. That's a great point. All right. So, couple reminders to you all. So we're at that 35, so we'll go ahead and get started on the lab, and I'll start detailing what that's going to look like. Please solve this problem on your own outside of class without looking at any. Literally, just go to the problem set, look at the problem with just this. Without looking at my worked out solution, without looking at your previous worked out solution. Because at the end of the day, how do you know that you're ready for the test? You prepare for it. You approach problems like the test is going to look like. On the test, you're not going to have the guarantee that you'll have put the solution on your note card. So you need to be able to do this problem fresh. Give yourself a day or two. Give yourself time to actually forget kind of give yourself time to not have the memorized solution down. But please do try this on your own. Study for, at the end of the day, when you want to, how do you know you're ready for the test? That you can do these problems without looking at solutions. If you have to look at worked out solutions to be able to do these, it's not going to go well for you on the test, because the test you're not going to have worked out solutions to reference. Anything in life that you need to prepare for, you should practice in the way that the test is going to look like. Eventually. Use the supports, use those kind of things. So if you're trying to solve this problem in the future fresh and you get stumped, then yes, reference the worked out stuff just to give you that next little bump, and then try to put the solution, the worked out stuff away. But at some point you should be able to do this without looking at it, without the worked out solutions. That's just a good recommendation for anything that you're preparing for. Any test, any assessment, at some point you need to be able to do it beforehand and the way that the test is going to look like. All right, so that's one recommendation. The second thing, and I had a lot of good questions about this, you can actually think about this problem in a different way. Because they're both moving 3 meters per second, you could actually have made their velocity any number. I could have made their number 10 meters per second, 20 meters per second, or even 0. If they're both traveling the same velocity, this problem is exactly identical if their velocity was 0. So instead, you could have had them both at rest. Pablo starts accelerating. How long does it take him to travel 50 meters? It actually ends up being the same way. And you got to see that mathematically. When you set these equal to each other, these terms cancel out. The initial velocity ends up canceling out. So conceptually, you can kind of understand that, and mathematically, it also shows itself. So that's just a kind of interesting thing. That's just kind of an aside. All right. So clearly we didn't finish the PowerPoint today. That's fine. 1D kinematics. All I have left over to teach you all, this will kind of roll into Monday, which is no problem. I'll just give you all an extension on the quiz. Gravity. We're going to work in problems where basically A is negative 9.8. That's it. We're going to do a bunch of problems with kinematics on Monday with that. And then we'll also get into 2D kinematics. 2D kinematics is these exact equations, but you have the pleasure of doing them twice. For X and for Y. Remember, vectors, you have to break into X and Y components. So we talked about vectors. To do anything with vectors, you have to break into X and Y. So you get the pleasure of doing kinematics for the X dimension, and you have the pleasure of doing kinematics for the Y dimension. But the good news is, the equations are the same. So next week, I'm not going to actually give you all any new equations. But we will apply these to different gravity in 2 dimensions. It'll be a great time. So we're not really behind. This is kind of expected on some level. Kinematics takes a bit to cover. We got plenty of time to do it. So moving into the lab. Okay. So this is going to be a fun situation. Oh, yeah. I actually need to do this. So this needs to close. I'm going to do a new session. Oh, yay. Whatever. I'll sync it later. All right. So this is going to be a common theme on lab days. On lab days, I'm going to take attendance twice, because if you're here in the beginning of class, great, but for the lab, I also need to make certain you're here. I'm not just going to assume people don't disappear between the beginning and the end. All right, so great, there's our time, so we're going to do we are not going to do, hopefully this will work. If not, all my trials are for nothing. So we'll take attendance again, and then I'm going to kind of walk you through what we're going to do for the lab, and the structure for this lab will be the same structure that we use moving forward. How it's groups and all that kind of stuff. So I just need to, today, kind of give you the logistics of it. Moving forward, we should be all right. Way to go. Go QR code, go. Same thing, if you are here and it's not working for you, my lovely LA will go around and get your name.
I'll just use the back of this.
That's perfect. Yeah. And you have to be, you all are present, so this is no problem. You only get lab credit if you're actually here. And lab credit, basically, if you do all the things, it should be all the points. If you're here, you should get all the points. If not, you can get none of the points. Binary system. Sure, no problem. You know, stand up if you need to get closer to it. It's good, stretch your legs. Get their step goals in. Yeah. Oh, the sign-in thing? Yeah, he's on. I'm just using this for this. Yeah, so for... Otherwise, I have to figure out how to do a new attendance section for iClicker, which... Otherwise, you just go to this website, scan this thing, and it'll mark you as present. Yep. Not working. Yeah. Yeah, it didn't sync. Is that the one we just did today? Yeah, it said it didn't sync, so I just have to hit sync button. Yeah. You are welcome to go to the modules and start looking through the lab. If you kind of got this done, you will need to open it up on some device. We actually have an assignment with something for you to turn in today. Because today is our first grade lab. So you can start previewing it if you're waiting on attendance. No, so we'll get to that, yeah. Only one of you needs to have it open. It works? All right. Okay, so getting into the lab. The first thing we have to do is figure out how for you all to assign yourself to groups. I have made it possible to have groups, but I do need to figure out, has someone self-assigned themselves to groups in the past? In any class that you've ever had? Anyone? Oh, no. All right, let's see. Wait, Leo's done it. Leo, how do you self-assign to groups? Great. Can you all see the People tab? No. Excellent. All right, let's address this. Through the power of dragging this upwards. Do you now see the People tab? Yay! Someone said yes. All right. Let's see what this looks like. Oh, there's a Groups tab on it. Look at all these groups. All right. You all can self-assign yourself to groups. It is a cap of 3 people. So if you try to add more than 3 people, it'll say no. Pick a group. It's going to be a great time of multiple groups trying to pick the same groups. I recommend probably scrolling down and not picking one of the first ones because everyone's going to be trying to add to the first ones. It's going to be chaos. Hopefully we only have to do this 1 or 2 times. This is good for our mental health. So everyone will need to do this at some point. If not now, later on, I recommend doing it now. Let's spend some wonderful time doing this. Alright, let's figure this out. 1, 2, 3, 1, 2, 3.
Lab attendant.
Well, this table I think has 9 people already. Oh, 2 is signed. You are just going to have to find some place in the room at some point where it actually fits. Yeah. Because that stands there. And then ideally you'll be next to people. That's fine. I'm not too worried about it. Yeah, that's fine. So you can just hang out. Yeah, you all will probably want to spread out because we're going to do stuff with ramps. And it's not going to be room over here. Yeah, that sounds like. All right, let's look at the chaos. Oh, look at all these groups. You have to be within the same group as someone else because when the TA grades it, the grade will get assigned to everyone in that group. So if you're not in that group, you don't get the points, and that'll be very sad for you.
Alright, you ready?
And I have exactly 33 groups because there's 99 students in this class. Divide that by 3 and you get 33. So I also only have 33 ramps. Conan, whose group are you in? Are you in their group?
I have no idea.
You gotta find a group.
Who does not have a group?
You all need a person?
Yeah.
Conan, do it then.
Come on.
You joined group 33, so maybe you may sign yourself, I think, hopefully. 31, shift yourself to 31. Alright, how we doing, everyone? Most of you still looking empty. You need to get this resolved. I'll give like 5 more minutes and I'm going to tell you what to do for the lab. And then you can attempt to resolve it outside of time if you need to.
I'll join group 17.
So there's actually no way to eliminate this part. So if you want to just log in.
Alright. It seems like the chatter's dying down, which I take as a good sign. That or you're just internalizing the struggle. Either way is fine. But do make certain you're in the lab group before you leave this class today. Because if the TA starts grading, I don't want to have to deal with, I didn't get the grade, and then we find out you're not added, and there's a bunch of, we want to avoid a million emails. I'm happy to answer emails. I just don't want to answer 20 of the same. That means generally something didn't go smoothly. Alright, so now you're in a lab group. Yay! This could be the same lab group. Ideally, you'll continue to work with this group for the rest of it. The alternative is that we'd have to shift everything around. But once these are made, we hopefully won't have to do this again. This also kind of forced people to find a seat with 2 other people, and so maybe, this works out great for everyone. Alright, so let's go over to, how is this going to work? How is this going to work? So if you go to the Modules tab, I am more organized today, and I've already made the assignment. Look at me, Mr. Organization, Dr. Organization. Alright, you're going to open this lab document. It is a Google Doc. Because then it opens on everyone's computer and we don't have to worry about formatting things and it's a good time. When you open it, it'll automatically say, do you want to make a copy of this? You do. You do want to make a copy of this. I really hope it says that at least.
Yeah, that is.
Because that's going to let you edit it.
Wait, you already did it.
Notice in all bold with 5 exclamation marks. When you eventually submit this, it will be as a PDF. And if you're not sure how to turn a Google Doc into a PDF, I will teach you at the end. It's just file, export, PDF. It literally will not let you upload anything but a PDF. Why do we use PDFs? This is a good exercise in, I don't know what to call this, but PDFs will always look the way that they did on your computer. If you make a PDF, it's basically a picture. So when you upload a PDF, I don't have to deal with any formatting nonsense. Otherwise, any other file format, Word, or whatever Apple uses, or anything like that, it can get all messed up, and we want to avoid that. Okay. So, look at that. It does make the copy. Yay. So, you make a copy. All right, let's look through this document together, and I'm going to kind of run through the procedures.
We already had someone in our group. We just joined our group.
Okay. I'm actually going to scroll down to the bottom first, because I want to point out something to you all. Again, the most important. Look at that. It's all bold at the end. Before you leave so this is very much going to be a once you're done you can leave situation. But before you leave, you need to have either me, the TA, or the LA come and quickly look over your work. Why? Because this way you get all the points. Various parts of this are worth various points. Here's what will happen. When you have one of us come and quickly look it over to make certain everything's good, you will tell us your group number. We will write down your group number. That means that the TA will then just give you all the points. If we do not have your group number written down, that means you did not check with one of us, which means the TA actually has to go through and grade your work in detail, which means they likely will end up taking off a point here or there because no one checked it over and you might have made a mistake. So this serves two purposes. It makes your TA's life, Angelina's grading, much easier. She just gives the points. It also benefits, the benefit to you all is it lets us actually check over and see if you did it correctly. And if not, we'll say, hey, fix this. This is not quite right. So we can also correct any mistakes and help you learn effectively. It's a win-win. Everyone's happy, right? If you do not check with us, the result of that is she will go in and check it, and you might have had a mistake, and you might lose some points. If you have us check it, you should get all the points easy peasy. All right? So that is going to be true of every lab moving forward. All right, to that end, what are we doing in today's lab? This lab is going to look very similar in what I ask of you from what you all did last week. But the context is different. So, observe the corner over here. That is where the ramps are. Don't grab anything yet. I'm going to walk through the whole lab because once the chaos starts, getting everyone's attention again is a nightmare. There is 33 ramps over here. I hope there's 33 ramps. I'm fairly confident. I have 33 groups, or less, so we should be good. You will send someone to get a ramp. Something that can, we have carts. I'm going to get those out in just a second. So a ramp, a meter stick. The ramp actually has a measurement along the side of it, so you actually don't need a meter stick. And then a cart. These are the only three things that you all need. We're going to use a timer that's on your phone. Super easy peasy. All right, boom, here's this thing's so heavy. All right, I am not going to lift this thing out. I don't know how much I trust, okay, it's fine. It's like I don't know how much I trust this plastic bin. Cool. All right, there you go, grab a cart. All right, here's what you're gonna do in this lab. It walks you through it so you can read the words. But just to make certain, a general review, it's like last time. So last time you dropped a coffee filter at various heights and you measured the time. This, you're going to roll a cart down at various distances. Note on this picture, distance is not how high it is. Distance is measured the hypotenuse. It's how far up the ramp. It is distance right here from this. You are measuring this. Not height, not height. You are measuring this distance, okay? Very, very important. It's actually labeled on the cart, on the tracks. Okay, you get to choose the angle of it. I'm going to let you all figure out how to measure that angle. That's a nice little puzzle for you all. There's many potential solutions to finding this angle, but that is something you will have to do. I'm not going to tell you how to do it. That's up to you all. You can think about how to do that. That angle will be set. You set that angle, you keep that angle. If your track shifts, you better be able to get the same angle again. Otherwise, your dad's going to get all jank. All right. You all need to open either Excel or Google Sheets. Just like last time, we're going to organize our data collection in Excel or Google Sheets. You will collect the time, the distance, and then you will calculate the acceleration. But how? There's a detailed thing about the equation to calculate the acceleration. And then again, the process is just like last week. Make a graph. Set an equation for that graph. Now, in this case, you're going to notice that when I ask you to set the equation, it says so you're going to make the graph. You will copy and paste it into this document. Anything you all collect goes in this document. We use Excel and Google Sheets just to do the organization. Then you copy and paste it into this document. This is the one you submit. Do not submit this in another document. Okay. Anywho, group stuff, that's just a check off. All right. When you fit the equation, you have to decide what type of equation. Linear, quadratic, exponential decay. Another fun puzzle for y'all to figure out. Anywho, and then so on. You set the thing, r squared. It is what we did last week. But now you're doing it yourself, and you're doing it within a slightly new context. This is going to be a theme in this class. I will have you all during labs. You will collect data. You will put that data into Excel. We will then interpret that data, make sense of it, calculate things with it. And some of that stuff will be values, some of that stuff will be the means and the standard deviation. So half of these labs is the physics with the equations. The other half is data analysis. Because anything you all do in life, anything you all do in the future with real measurements, you're going to have to learn how to analyze data. And Excel and Google Sheets is a nice intro to doing that. In the future, you use fancier programs, but they'll have the same functions that Excel and Google Sheets do. So that's why we're using it. It's very handy. It's very useful. And there you go. Each of these design points. And then, yeah, just remember to ask us questions at the end. At this point, any general questions, please ask them now, because if you have a question, probably lots of people do. All right. As the chaos ensues, if there's common questions, I will do my best. I will get everyone's attention and clarify that response to everyone. Last thing, remember, what are you going to upload? File, and then there's some way to download as PDF. And that is what you will submit. Someone in your group has to submit this. And then, yes, at the end, have us check off your stuff and tell us what your group number is, and we'll write it down. And you'll be good to go. One person does this and you're good to go. One person submits it. You can do it on multiple, but only one submission is necessary. Oh. You cannot be in a group by yourself. If you're in a group of one, you better move. You got to find other people to work with. You cannot be in a group of one person. So, if we see that, we will find, you need to find other people. If you need help with that, come talk to us. We'll find it for you. You have to have at least 2 people. Ideally 3. Yeah, so Leo, when they check it off, I don't know if y'all heard it, so just when someone does call you over, and if everything looks good, ask them what their group number is, write that down.
Like a sheet of paper.
Yep. And this is going to hopefully make your grading easier, because then you'll just be able to go through those groups and just all the points, you don't have to take a look at their section. Yeah.
Like there are 3 groups with 2 people, so I don't know if it was put this group together and make 2 groups of 3 people.
It's fine.
It's fine. Okay.
Yeah. As long as all I ultimately cared about is that we didn't exceed 33 groups. So we seem to be fine today. So that's good by me. Yeah, group of 2 is fine. It works. Yeah, thank you.
Oh, I guess not.
Yeah, so I'll write mine like mine.
Yeah, and I'm hoping that when you grade submissions, you can do it by group. I honestly, so some of this is just going to be kind of figuring this out. I'm hoping you can sort by groups and do that. Because it is a grade by group, so we'll see what it looks like. My hope is as soon as you're grading for labs, it should be.
I'll probably like first switch to that spreadsheet to be safe, and then.
Every single drop is from the same angle. Choose an angle. Do not pick an angle that's ridiculous. 80 degrees is bad. Don't break my cart. You get to choose. You're measuring the distance. You can do the same distance. And also do different distances. Don't do the same distance for every single one. You need to make a graph with different distances. So, vary your distance. You can do the same one a few times, but do not do it for all 15.
That's how you trying to write together. Usually by the time they get around, you have to. It's popping an error message when I try to put it in.
You have an extra equal sign. So just get rid of that extra equal sign. That equal sign is going to be So get rid of the equal sign in front of B2. And then get rid of the equal sign. Yeah, you only put the equal sign at the beginning. And now.
Okay,
It was just
Formula for time. Yeah.
Alright.
So that's the one that's the one you're gonna end up using for this week's one installation. Why would we keep?
I don't think we need to know the actual rate. We'll just say
Yeah, we need time, distance.
Yeah, I think it was just saying like intuitively speaking,
Yeah,
keep the angle the same.
the angle should be the same for all of the points.
Oh,
the
okay.
mass should be the same.
And that's assuming it velocity.
Okay.
And we can obviously That's a good question. Thanks, Russ.
Actually, I just realized since you have a document open, you should open up a Google Sheet because you have to copy those.
Measure distance from the front of the cart. If you didn't realize that, distance is from the front of the cart because the front of the cart is against the ground, not the back of the cart. Yes, you're just going to put it somewhere. I was doing it because I can measure the distance, and so I flipped it around because now whatever number it is, that's the No, once you set the angle, you're good.
Alright, let's get this data collection. We might want to better angle. I'm not gonna lie, because that's gonna be hard.
No, it's chill, bro.
If we do any steepness, it's going to be even quicker.
Yeah, I'm not saying steep, I'm saying
I mean, they can like.
Well, that's too steep.
I don't feel like
Actually, that's
I feel like it'd be easier with time.
I'm not being.
Second and 8.
What's each one take? 10 seconds. 15 trials. 104. Keep the angle constant. It's a very good question. Keep the angle. Once you set it, leave it. Change the distance. The distance is the only thing you should be changing. Do not change the angle or your graph will be not good.
So what was the distance on that one?
I am very much on a week by week building class. One day I'll get it. The lab will kind of always follow. One week the next this week.
Is it 104?
Yeah, it starts at 60.
Yeah, we can change it.
So I'm using this lab, so we might use Tracker. How much time? Tracker is great, but I will only. I'd have to teach it on this Tracker.
Okay, hold on. Either I time that. Oh no, that makes sense. A minute is a second.
Yeah, what's it?
I'm trying to do that time, right?
Yeah, so
we do like this.
you're gonna make it like this. I set it up.
Oh, okay. Thank you.
Make sure you set up your Excel document the way I did, where time is the first column, distance is the second column. Otherwise, you make a graph and it's backwards. Also, don't forget to convert centimeters to meters. All the things class.
I mean, it's the same. Yeah.
Second and 11. That was a second. Whoa, hold on. Let's redo that. There's no way. A second 13. Literally just 111.
There's 111.
This one's 113.
You can just keep going. This one is at 94.
If I ask you for it, you
I was a second 3.
03.
Yeah, someone else wants to time it.
Let's redo that data point one more time. If you get like down to
Oh yeah, the fun thing. So you can actually just use it.
I know this is one of the smartest things you can get, but like it's like human error the amount of times.
I mean, bro, look at everyone else's, bro. Theirs is gonna move a lot quicker, bro.
I'm not understanding how they're getting valid points through that. Like, there's no way they're gonna go. They're going. You know what I'm saying? It's like click. It's gonna be like 0.05.
You wanna try it? Just for the one time, we can see what it would be like.
Yeah, we'll be able to.
Whoa, that's really good. That was 0.4.
Yeah, see, that's gonna be so difficult.
Oh, okay. They're doing like ours, so I mean it's fine. Whatever.
Alright, right now we got 92.
And yeah,
Second.
So we did not start.
Second.
I feel barricaded.
I feel like I'm doing it wrong, but I'm not. That was way off. That was on me. That was on me. Second and 5.
I feel like I'm physically seeing it go slow. And
Yeah,
at
that's
the
what
same
I
time,
am.
like I just feel it. But we might not. We might take it more like
Second and 8. Second and 6. Whoa, redo that. Bro, you can fucking try if you want. I had 90 there.
Just give me a countdown of when you're gonna let go, and that's what. Yeah, see, I fucked that up. I like that.
Yeah, it's gonna be tough.
I got 0.78.
Yo, unless I've been fucking listening.
Yeah, here, try it again. It's just like, he's not gonna be like, oh, human error. You know, he shouldn't have to.
A second and 1.
A second 01 or a second?
Second 01.
What's the lowest?
I didn't stop it. I was like, shocked.
I started out really late. So I think we redo that. I mean, really early, so I started at really
your distances need to be varied, but you can literally just send it at 15 random spots, write down that number and time it. They don't need to be evenly spaced, they don't need to be specific values, they just need to be different numbers.
Yeah, one more. Seven.
Alright, we got one.
second 16.
Well, 9.
It's so annoying because can you make like Google Sheets do a certain equation for you? Because if you can't, then we have to manually do it.
Can we make it what? Say that again?
Like we can't make Google Sheets do a certain equation like that we tell it to, right? Because if we can't, then we have to manually do it. It's not too bad though. It's not that many parts.
We'll have they're all like I think I just don't know how.
Nah, honestly, I don't even care to find out because it'll be quick. Can I move my bag really quickly? Or one more go?
Alright, I think I had way more confidence in myself.
I figured my guy did.
But
Oh, I'm gonna go back to the
we'll talk about it. So yeah, basically, I'm not. A lot of this is just seeing do they think it's work, and then having those conversations. I'm not worried about getting exactly what it was. If your dad's super good, I don't have the time for this. You know what? So when you're going around, we're gonna start at 7. If they show you the graph, yeah, and then you kind of comment, oh, what should it be? You can ask these questions briefly. You won't be able to spend much time with each group, but hopefully at least half the people will finish before the time. And your grading will be easy. I did make a rubric as well, and literally the only reason. Make sure your distance is good.
Okay, yeah, so you want it from yeah.
No, it's fine. The lab sheet shows us like a really quick one. We're doing the calculator over and over. Honestly, just use the Google Sheets and make it right. No, but that we're not gonna put acceleration on it, right? Pretty sure. Like here, look. It just says it's whenever you're done making the graph, let me just sit down and I'll do it.
I think I was just a little bit delayed.
No.
Yeah.
That was what we're I'm not bringing this up for sake of creating this. You know, these are good. 3. That's actually good. Technically, your displacement. That's how my. At any point in the process, if you have questions, call us over. 3 of us. We're here to help. On tempo. 3. 2.
Like after I say 2.
What the fuck?
So that's count 3.
Is it supposed to be distance versus time?
Wait. I pressed the wrong button.
That looks so gross.
These are actually
Yo. I don't even, this doesn't represent any graph, right?
That's actually 3 questions I did put in here.
No, yo, what?
that looks a little slow.
Okay, I didn't quite put it there. I just
Other people's graphs also look really weird with the lines.
I feel like the lines
Makes sense.
That looks so stupid.
I like the access to
It's gonna get harder and harder.
It's not that.
I don't even like what graph even is that, bro? Y equals 0.
This is the distance, and this is the distance.
No. I'm talking about because they're gonna ask us a question. What does it represent?
It represents it apparently at 76 grade distance. So we did 76 at grade. That would be our lowest time. And then our highest time goes on as the time gets on. And then in our reasoning part of our lab, we do like the human reaction time. There's no way. We have like a 0.5 second buffer, so our graph wouldn't make sense. 0.05 second buffer or whatever. But it's for reaction time. Are you guys figuring out what I'm
Hey,
We should do a higher.
we're gonna do the acceleration. I think we have to put the numbers in there too.
You can help me puzzle this. Why are we getting graphs on there? It's not what I want.
It's copy.
Oh, so when y'all make a graph, make certain it's a scatter plot. Make certain it's a scatter plot like last week. That'll plot each data point. Yes, Google Sheets will try to guess what you want, and it seems to guess wrong. You need to know what type of graph makes sense, and anytime you collect 2 data points, it's a scatter plot. If you want to see the distribution, you do a histogram. If you want to see how 2 variables relate to each other, it is a scatter plot.
Yeah, don't we need it's like an average or something. Just put that like, straight through the middle of it.
Dude, it's so early. It doesn't make sense. I don't
How accurate is your? I need to add a question about word 5. This always be here. Anytime y'all do a experiment, it's always going to be here. 88. You know that error is. If you want to I'm not going to tell you the whole thing. So you're fine. You're fine.
There we go. That makes a little bit more sense.
But hey, I didn't expect, the nature of doing these labs is this is part of the conversation.
At 20
Look at that. There's an acceleration being equal in
I'm trying to make it like
it's somehow different. Okay, so you don't want to put the units, you don't want to put letters, numbers.
as you put them in. Actually, yeah, and then I can just tell you what it says.
And the reason it actually was really sorry to figure out the numbers, but it's one of those like
distance is in meters.
Yeah. 87.
I'm not gonna lose
Okay. Alright, guys.
Second one is 1
No, we're
point.
still. Okay. 66. 3.
I tried getting in contact, but there's someone coming.
Yeah, that's exactly the time. Always.
They just wanted me to tag first before I got
Oh, we need to do. We forgot one. Why we need one more?
Just look at this.
What'd you say?
1.08.
By both parties. By either.
That's part of this. Why does that have, like, thinking about those things?
Should we put our chart in meters?
The reality is, I was hoping this down. It's not data collection is not very good. That's fine. That's part of the process.
I didn't know it was meters. I was just fucking
Oh, we didn't.
Wednesdays I have a set of
That's good.
So yesterday I actually missed the class. So I'm not gonna
that works for me.
I literally walked. I made it like right on the dot.
That's exactly so time does always go up.
Until like waking up. I'll take a class as far as I can.
Oh, okay.
You know, so let's see.
Yes, they are happening. So if you look at this one, time is happening. See what time it is.
Just delete it.
Now, super simple.
Yeah, it's actually changing the voice.
If you want to switch these colors,
It's not bad, no, it's not. I'm just saying.
if you do it in Google Sheets, Google Sheets automatically will add actual photographs to Yeah, as you all get near the end, once you have a TA check-in, again, make certain they write down your group number on something, and if they have done so, you're free.
Like originally, so like we look at the one.
Yeah, so exponential is the hour. What's that? Okay. Yeah. So that's really not your Yeah, most should do this. Because I don't know why. Yeah. That's what I was thinking. Right. All I did was yeah, your dad looks really good though, actually. I did. Yeah, there you go. So you're also, you all have a yeah, so we're gonna dig. We're gonna do that. Okay. So you have your equation. So this one here shows linear. And this is where it kind of realizes so the equation that we're using. It's power.
That's my fucking new there.
We'll figure it out. What is the
Like this, if we use this switch, just change it to 1.3. This the data here is crowned. Like, not yours, ever. That's just so that was kind of what I was hoping would happen in my mind. I was like, we're great in your equation.
Oh, this is what we have to average. What I'm so
Looks like that. That was the dream. I'm gonna straight up tell you all. Like, you should do this. Not this. Whatever, it's fine. It's fine. So clearly it's not perfect. Yeah, it's the idea. I'd say trust the process, don't trust the process. Okay, something to write down.
Now we have to close and make it.
Someone checked your stuff? Yeah. Great. You're good to go? Have a good one. See you then.
The graph can generate. Okay. You have to go back to
And to clarify, I am not looking at your old things. When your TALA and you come around, we're not looking for right answers. We're looking for thought process. So, don't worry about precision when it comes to this. I'm not looking to say, oh, you got the right number. The purpose of these labs, almost every person in this class got terrible data. That's part of the process. Think about why the data is bad and all that kind of stuff. There's learning in that.
Yeah, that's
I was working. And I got home with my pet, so I had to fight it. I live in a car. No, I'm not really. It's not fun. There's a big ass hole with like plastic all over it, and like clear straws. Yeah, based on this question, what is the acceleration? And we got a little hint here.
Yeah, right in that category.
Like, that's what part of the
So number 4, part C, because the data is so lousy, I was really optimistic. I was like, man, this data will match this equation. And people realize, oh, it's going to be a polynomial. Or, a quadratic. And then they fit that, and then your equation would look like this. And then you'd be able to get acceleration by looking at the term in front of the x squared. Whatever, that was the dream. The dream did not pan out. So to that end, if you are on number 4, part C, you're like, how do I do it because mine's linear? Just use the average acceleration that you can calculate from that. That's fine. We'll use that as a workaround to avoid headaches. But the dream is that it would have fit this, but it doesn't, so here we are.
How good of a fit is the equation to the R squared? Neither do I.
Yeah, exactly. You're trying to figure it out.
What is that?
Yeah. Have a good day.
They're American. We're dogs. Okay.
This is
Just because they're gonna tell them.
It's an interesting why they call it. I know it. So the other labs that exist, the ones I'm working with, they're trash. And so my hope is with this class that it's almost like a piloting lab that maybe could be used within an hour, 20-minute time, Yeah, and then I got jumped in, sorry.
Am I wrong?
That's always, you know, I think we can do trials and still be crap data. Where is your biggest source of error? Okay, be specific. Be specific. What about so what would we do? What could be done? What could we do like that?
Calculate the mean value standard deviation.
And then those are free.
At least I know the standard deviation. I forgot how to. I don't know I don't think the graph does it. I think we literally have to put under our points on both sides.
Stop cutting myself. I don't know, y'all. So, it's like in a table. You see this? Like it's selecting it.
That's good sign. Very minimal. Yeah, so download.
What's your
Maybe or are you all done?
and standard deviation
Like I don't really like I enjoy myself just whenever I'm like 7:30 Fridays and Mondays I'm those are like the fun
I'll just look through everything.
How long is it?
So that's it. Here, it's done.
Getting to campus is like a 5-minute walk. The part of campus that I entered is like across the
Okay. But so how do I know like that I found makes sense for me? That's kind of what that's It's a lot smaller than gravity, but maybe there's a reason behind it. It's kind of like thinking about why it is the way it is. So it makes sense that it's smaller than gravity.
I would say I'm doing fucking math, but I don't know how to get a
I like this. Get off your leg and come straight here. So you're going to be like
Well, if not, I can
just say that. Or I was saying going down a bridge. I don't know what bridge you're going to, but mine.
You're good.
Really? Oh my god. No. Like, I'm still like before I like oh, what makes sense is like that's literally the bridge I was so I guess that's 40
Yeah, last one. It's good that they fucking $14 and you want to be like baby. It depends, bro. It depends. Sometimes they'll give you an extra meal.
and
I honestly cannot like that. I cannot see that.
I would say
There, bro. I just I don't like their teriyaki. And I love teriyaki.
I would say unless you mean and then more active. Yeah.
I don't know why it wouldn't be.
I'd say that. I think that's fine.
Because it's not very large number, so it doesn't deviate from the other numbers.
You're good. I mean, but it was, you had to make some
If you look at them, they're all pretty much like separate.
I guess we could just say like this shit is low enough that it's pretty accurate.
They look like the same numbers, and you can still count the numbers down and the concept.
Getting good at is hard, and this is Alright, I'm swinging around. And then I'll swing around here. Alright, he's there, so we'll hopefully get y'all next time. Alright, so we got this stuff where that is. That's good. Because of my reaction, right? Alright, this one.
Well, I think
Yay! Nice. You all recognize what is it? I haven't crossed it yet. Go get a number. If I drop something straight down.
Yeah.
So we're gonna learn that on live on a heel. So if something's falling through the air, it will accelerate to You got a number less than that? That's good. Because it wasn't falling straight down. The angle, you get a decent with that. Ooh, I like that. Keep increasing the distances would help produce some of that air. Yeah. Now there is a way to go, and I didn't have y'all just you can really accurate that up when it starts So the stop punch was with our finger, but that was so tricky. You had to kind of eyeball it. What could you use with your phone? So y'all can think about it. There's something your phone can do that would let you actually get the time version of the seconds.
When the teaching assistant. Oh, she did.
You recorded. You have a video of her.
Bro, I want a gun. But thank you. I want a gun though.
And so you could actually
Too long, or you just don't come with the color?
No, I don't fuck with the color anymore. Like at first it was good. My hair was shorter. And my hair was alive. I was just shed.
I was the same way. I shaved my head and then I got.
It's one of those. I didn't have y'all doing
Eminem.
What's y'all's group?
It just like towards the end it just started
20?
poking straight
That's
out.
what I'm saying, bro. I want a gun.
21.
Like fuzz, or just a trim?
Yeah, and then just.
Nah, I'm waiting for it to grow out. I just want my hair.
Buzz it. It's gonna be the most life-changing experience ever. You're gonna get no notes and you're like, "Fuck, what am I doing wrong?"
You gotta get there though.
Yeah, you have to.
I'll never do
It's
it,
a
man.
must. People come up behind you.
Yeah, literally.
Alright, let's turn this into
It would look like a fucking chili, bro.
Hey,
Excuse me?
walk in here.
Excuse me?
Oh, you want calculator?
Excuse me?
It's fine. You didn't do anything wrong. You all did it in the calculator. So remember in Excel, you can actually, do you have time for this kind of fun? Remember Excel can do I guess I'm right now. Equals 2 times the distance divided by you can type this stuff in, you hit enter, and then it automatically does it, it automatically adjusts. I know this one. Super nice, that's gonna be really helpful in the future.
And for acceleration, time, right? But acceleration comes from when it's multiplied times. So like in an ideal world, you would have got a quadratic relationship, and that would have been acceleration. So what was inside before is instead of using like your trend line to get the acceleration to the linear one, you're gonna take the average of these numbers underneath, which I imagine you already have. So just like go in and type that.
This is one of the reasons we're doing these classes. Learning how to analyze data, and standard deviation tells you to spread it together. So 6 says that 60% of your data falls in one standard deviation. 90% of it's really helpful. Good. This stuff is super useful skills. You will analyze that at some point. Oh, that was it. All right. The last two questions are some of the most interesting ones. At the very bottom, is really what I care about. The question is it reasonable? So, I haven't taught you all this. I'm going to tell you acceleration for gravity is 9.8. So, if you're on a ramp, you get more than that. What did acceleration roll? So acceleration, yeah, you get less because you know
So
you can
just
imagine
change those two
extreme
numbers
example
in
of
there.
flat.
And
The other two tell you straight up and down.
Yeah.
17.8. So it's okay. That's okay. The purpose of this is to get the it's the one part that asks does my answer make sense? Because and then you can think about why is there. So that's the next one. Where was the biggest switch off So what could you all do to much more active? You're the third people actually think of that. Yes. The video is out because your camera records 30 seconds. So you can actually get I specifically told about that. But it is something to note. Your phone has an insane amount of sensitivity. The camera is one of those. Your phone actually has it set But yeah, give me just a video tape. Let's roll this. Download PDF, upload and all that just in case. Yeah.
Great job, guys.
Yeah, here you go.
I might scroll up again. I'll be to Like 3:30, I think it's when we're starting the center. Alright guys.
Did you guys get yours signed off already? Or do you want me to?
It's really simple. And then you can get
One person has your group.
You can't see that anything has changed. But behind the scenes, this is kind of a programming thing. Right now, it printed it as a string. And so my hope is that that was the problem. That's usually the problem. This is fine. We're gonna figure it out. Yeah. That is very
Did the professor leave already?
Yeah, I've never seen so happy on bunch of this.
How did you do it so good?
Should you find out one?
You like on your own.
And this might work with
Oh, yeah, I did try. Like, scatter and gave me
No, it's not. That's wild. Oh, okay, that's fine. Okay, so you said that. I was like, maybe someone did something so weird. I do ask, go ahead and still upload this is just a backup and put someone like at the top.
Now we got way too many chairs.
Well, that was a healthy one. I was entertained. Yeah, I have no idea why they do this. I found it. Leo, how confident do you feel in picking up that cart down there? that bucket of things. And I was like, I can